So I'm going to go ahead and finish up these notes so you guys can be able to move on here. Number 10 says to determine the points at which the graphs of the following functions have horizontal tangents. So think about what that means. Remember that our tangent line, we think of, when we're thinking of the tangent line, then we know that we are trying to find the derivative, and it's related to slope. And if we want a horizontal tangent, then we know that the horizontal line has a slope of 0. So we are looking for where f prime of x equals 0. And just like I had said, you'll see these directions a lot. Find an equation of the tangent line. You're going to see that a lot. You're also going to see this a lot. Determine the points at which the graphs of the following functions have horizontal tangents. You have to read directions like that and know I've got to find the derivative and set it equal to 0 and find out what those points are. Now, since it says determine the points, that means we should probably report that as an ordered pair. So the first thing I'm going to do is find the derivative. That should sound familiar because it seems like the first thing we always do is find the derivative. So I get 2x plus 2. And then what do I do next? I got to set the derivative equal to 0. So I set it equal to 0 and I solve for x. So x equals -1. So the direction said to find, so that's the only place when x equals -1, which makes sense because it's a parabola, so we would expect there to just be one horizontal tangent at the vertex. So, but I need the point, so I need the y value. So if I were to plug this back in, so I'm going to have to find f of -1. So I get 1 minus 2 minus 24, so we get -25. So the point where the graph of the following function has a horizontal tangent would be at -1, -25. Okay, I'm adding something else in here because I just can't help it. I get kind of excited about this. So let's think about ax squared plus bx plus c. Okay, so let's suppose that's the function. Very similar to what I just did, except just our standard equation here for a parabola. And let's find the derivative, because remember, when the tangent line is where this is a parabola, and so the tangent line is going to be a horizontal at the vertex. So let's find f prime of x. So I'm going to do, remember a, b, and c are constants, so I'm going to get 2ax plus b. So then I would take the derivative and set it equal to 0 to find the horizontal tangents, and I'm going to solve for x. So I'm going to subtract b and divide by 2a. Does that look familiar? The opposite of b over 2a. Remember how in Algebra 2, that's how we found the x-coordinate of the vertex, was by doing the opposite of b over 2a. You didn't really know why. Now you know why with calculus, because if we take the derivative and set it equal to 0, that's what we get. And I hope at least one of you that makes excited. You get excited about that because, it's just kind of cool when you see how math works. Okay, so now I'll move on. For part B, setting it up the same way, f prime of x equals 4x cubed minus 8x. And we're going to set this equal to 0. So I'm going to factor out a 4x, and here I'll have an x squared minus 2. Okay, so then we're going to set that equal to 0. And we get, okay, so from there, I can say, obviously 4 is not 0, but I could say it's already factored. So x equals 0, or x squared minus 2 equals 0. And here we get x squared equals 2. So x equals plus or minus the square root of 2. Now, we would have to find the y values. So I know it's going to be 0, 0. And then it's going to be the square root of 2 and negative root 2. I'm going to grab a calculator, but I'm going to pause the video so you don't have to wait. Okay, after I said I was grabbing a calculator, I realized we could have done this in our head because when you square a square root of 2, it cancels that out. So then when you square that again, because it's to the fourth, you would get 4. So you could work this out. It wouldn't be that hard, but I did it there. So we have -4. And if it was negative square root of 2, since you're raising it to even powers, you're going to get the same thing. So it's going to be -4. So there's going to be 3 places. Now, if you graphed this, you're going to see that. So if we were to graph, let me clear out this other stuff. If we were to graph x to the 4th power, oh, that's not right. Yeah, it is. Minus 4x squared. Remember, we're expecting to see 3 horizontal tangents. So if I don't know what my window is. If we graph this, notice I have 3 horizontal tangents because I have a minimum right here, a minimum right here. Notice where those are, approximately square root of 2, -4, so we can see that. And at 0, 0. So those are the places where I have horizontal tangents. Okay, same thing on the next one. So we're trying to find the horizontal tangent, so we need to know where the derivative is 0. So we need to find the derivative. However, we've got to use the quotient rule. So I'm using this is u and this is v. So u prime is 2x and v prime is also 2x. So remember the quotient rule, u prime v minus u v prime all over v squared. So we're going to get the derivative by taking u prime v. So we're going to have 2x times x squared plus 1 minus uv prime. So let's see, v prime is 2x. I'm going to put that first. And then u, x squared minus 3, just so that when I distribute, it's what we're used to, over v squared. Okay, so now we have 2x cubed plus 2x minus 2x cubed plus 6x all over this. So my 2x cubes cancel, that's kind of nice. So we have 8x over this. Now, here's one really nice thing. Remember about rational functions? I want to find the 0. I want to know when is f prime of x equal to 0. Well, think back to rational functions. We had a packet in college algebra that we went through, and to find the zeros, you set the numerator equal to 0 to find the zeros of the function. So we're going to just set 8x equal to 0. So that means x equals 0. So that's my x coordinate. And I need to plug it in, find out what f of 0 is. So when I do that, I get -3 over 1. So I get -3. So that is the point 0, -3. We would have a horizontal tangent. And you could graph that and check that. Okay, I'm going to do it. Okay, there's my graph. And sure enough, 0, -3, we can see that we have a horizontal tangent. Next one, we've got our function. So again, we're going to have to use the quotient rule. So u prime is going to be 1 and v prime is going to be 2x. Because remember, this is u and this is v. So we get f prime of x equals u prime v, so 1 times x squared plus 3 minus uv prime. So I'm going to put the v prime first since it's a monomial. So u prime v minus uv prime, so x minus 1, all over x squared plus 3 quantity squared. So we get x squared plus 3 minus 2x squared plus 2x over this. Make sure that's all right. Yep. Okay, so kind of simplifying this a bit, we get -x squared plus 2x plus 3 over our denominator. And I want to find the zeros. So once again, I set the numerator equal to 0. Now I'm going to try factoring this, but I prefer to have a positive x squared, so I'm going to multiply both sides by -1, which means I'm just changing all the signs. And with a diamond problem, I think we can do x, a -3, and a +1. So that will work. So we get x equals 3, x equals -1. And remember, we need the y values, so I have to know what f of 3 is. So plugging in a 3, you get 2 on the numerator and 12, so we get 1/6. And then we need f of -1. So that's going to give me a -2 in the numerator and a 4. So we have -1/2. So we get 3 1/6 and -1 1/2. Hopefully I did not make any careless mistakes. All right, now we're going to have to do some work finding f prime of 3, and we don't even have the functions. We just have some stuff that they've given us in a chart. And I like these problems, and I always find problems like this on the AP Calculus test in some format, whether it be a part of a free response question or multiple choice questions, but somewhere you are going to see something like this. So what do? Well, first of all, we're going to find f prime of x. But we don't have the actual function, we just have to use the rules. So remember, this is a constant times a function. So if you want to find the derivative of that, if you look back at the rules that we had when we first started talking about derivatives, we would just get 4 times g prime of x. Okay, so the derivative of 4 times g of x is 4 times g prime of x. Okay, then the next part, because remember, derivatives you can add and subtract. So for this next part, we're just going to get 1/2 times h prime of x. And the derivative of a constant for the +1 part is 0, so we just leave that off. So now we want f prime of 3. So I'm going to have to know what g prime of 3 is. And I'm going to have to know what h prime of 3 is. So hopefully those are values in my table. So g prime of 3 is -2, and h prime of 3 is pi. So my answer is -8 minus, and you could put 1/2 pi or pi over 2, but leave it in terms of pi. I mean, technically, I guess, from what I'm told, if you round to 3 decimal places, but just leave it exact. Okay, now for the next problem. Now I have g of x times h of x. Well, that's a product. I'm going to have to use the product rule here, so that makes this one a little tougher. So to get f prime of x, using the product rule, this is u and this is v. So when you do u prime v, it's g prime of x times h of x. That's the u prime v, plus, and then you do u v prime, so you get g of x times h prime of x. Now I'm done with the product rule. But I also have this plus x, so that's going to be a +1 because the derivative of x with respect to x is 1. So now I'm going to do f prime of 3, because that's still what they're asking me about. So I'm going to do g prime of 3 times h of 3 plus g of 3 times h prime of 3, and then I have a +1. So g prime of 3 is -2, h of 3 is 3, g of 3 is 4, and h prime of 3 was pi, and then I have a +1. So I get -6, I can go ahead and add the 1 to that, so -6 plus 1 is -5, plus 4 pi, and that's my answer. On part C, got to use the quotient rule. So this is u, this is v. Now what I would probably do is think of this as 1/2 g of x over h of x. So when I find the derivative, I'm going to take 1/2 times whatever the derivative is. And now this is u and this is v. So I'm just doing the 1/2 times the derivative using the fact that this is just a constant. So the formula, remember, is u prime v, so it's going to be g prime of x times h of x. So that's the u prime v minus u v prime all over v squared. Okay, so that's all I've done. So now I want to find f prime of 3. So it's 1/2 g prime of 3. Okay, I'm going to take a shortcut here. I know you guys are probably wondering, why didn't you just look at the chart? Since I've done a couple other examples, I'm going to do that. So I'm going to put in g prime of 3 is -2. H of 3 is 3. Minus g of 3 is 4. Times h prime of 3 is pi. All over h of 3 was 3 squared. So if we just clean that up a little bit, we get 1/2. We're going to have -6 minus 4 pi over 9. And then this 2 can cancel out a 2 if I factor that out. So I'm going to have -3 minus 2 pi over 9. And do not tell me that that 3 and 9 cancel, because I would not be very happy with that. Hopefully you know why. Okay, on the next one, we are, you can think about what rules we might need. Actually, there's a couple ways you could do this. I'm going to think of this as g of x over g of x minus h of x over g of x, because that simplifies to 1 minus h of x over g of x. Now, it doesn't get me out of the quotient rule, but it might make it a little nicer. I don't know. I mean, I probably could have just done it with the quotient rule from the get-go, but I'm going to think of this as f of x. So I'm still going to have to use the quotient rule. So this is u and this is v. So then when we go through this for f prime of x, the derivative of 1 is 0. But then I have a minus sign. So I'm going to treat that minus sign and I'm going to put parentheses there. Just like I pulled the 1/2 out, this is like having a -1 because I'm going to have to distribute that negative sign. So I want to be careful. So then I have u prime v, so it's going to be h prime of x times g of x minus uv prime all over v squared. Okay, so we had u prime v minus u v prime. Okay, that looks good. So f prime of 3, still got that negative out there. So looking at our chart, hardly have room there. H prime of 3 is pi. G of 3 is 4. H of 3 is 3. G prime of 3 is -2. And G of 3 is 4, and we're squaring that. So I have negative. Here we're going to have, that's going to make 4 pi minus 3 times -2, so we have a +6 over 16. So we have, I can factor out a 2, so we're going to have negative, I'm going to distribute the negative sign, so negative, negative 2 pi minus 3 all over 8. Took a 2 out and distributed the negative. Okay, so that looks good. So that's f prime of 3. So that's how you use a table. And oh, there's another one. All right, so just like we can find a derivative, we can find a second derivative and a third derivative and a fourth derivative, etc. You can continue to find derivatives, and they actually have some meanings that we're going to learn about in calculus. They will have a kind of a nice meaning when we talk about position, velocity, and acceleration. It will, we're going to see some things, geometrically with these different derivatives. So how do you find them? Well, first of all, you can't find the second derivative until you find the first derivative. So f prime of x, power rule for this one, so the 3's will cancel, you'll be left with 8x squared. And here we'll have a 10x and a minus 7. And to get the second derivative, which is f double prime, we have, you just do it again, 16x minus 10. And even though they didn't say to, if you wanted to find the third derivative, you would have 16. And if you had the fourth derivative, it would just be 0. And then every derivative after that would be 0. And so for polynomial functions, eventually you would get to that. We only have to find second derivative. That was extra. So on this problem, what I would do first is, I don't want to use the quotient rule unless I have to. Well, I don't have to here. So I can simplify this. So I'm going to think of f of x. So f of x, oh, the line always gets too thick, is x plus 4 minus 2 times x to the minus 1. So then f prime of x is 1, and this, remember, drops out. Then we have a plus 2x to the minus 2, and f double prime of x, the 1, the derivative of a constant is 0, so I get negative 4x to the minus 3. And I could, if I didn't want a negative exponent, I could say we have this for an answer. Now, in class, I had said sometimes you don't, like on the first derivative, I wouldn't want to switch this to x over, or to the x squared in the denominator, because then I'd have to bring it back up if I was going to do the second derivative. So you wouldn't want to flip that until you were, done with what you were working out. Okay, so for this next one, I'm going to think of this as y equals 4x to the 1/2 minus 2x to the negative 1/2. Then dy dx, and you could call it y prime. I'm calling it dy dx this time, is a fourth times, or a half times 4 is 2x to the negative 1/2. And here we would have a positive, and that's going to be a 1, x to the minus 3/2. Leave it like that. Then to get the next derivative, and did they show you that? Yeah, they showed you that here. So it's not dy squared, it's d squared y. So that's, kind of showing you that it's the second derivative. So you would write it like this with respect to x. So notice that it's, oh, we do need that down here too. I don't use this notation as much. I would use y double prime because it's easier. So I don't know why I chose to do that. Anyway, you just do this again. So a half times 2 is 1. So we get negative 1 x to the negative 3/2. And here we'll have minus 3/2 x to the minus 5/2. And I'm just going to leave it like that with negative exponents. You get the idea of what we're doing with the second derivative. On this one, can't split it apart because it's a difference in the denominator. You can't avoid the quotient rule. So here's u, here's v, u prime is 1, v prime is also 1. So when we get the derivative, it's u prime v, so it's 1 times x minus 1, minus u v prime, so that's just minus x, all over x minus 1 quantity squared. So conveniently, those cancel. All right, then I need the second derivative, so I'm going to have to use the quotient rule again. So this time, we've got u and we've got v. So u prime is 0, and v prime, in order to get that, we're going to have to multiply this out. So this is x squared minus 2x plus 1. So v prime is 2x minus 2. Okay, later we'll have a different way when we know the chain rule, but right now we don't. So we would just multiply out what v is so that we could get v prime. So then f double prime is u prime v, so it's 0 times v, so that's 0, I'm going to leave that off, minus uv prime, so that's a negative 1 times v prime, all over v squared. Well, I'm not going to use the multiplied out one. If you square something that's already been raised to the second power, that's just going to make it to the fourth power, because a power to a power, you multiply the exponents. So cleaning this up, this is just a positive 1, so we get 2x minus 2 over x minus 1 to the fourth. Oh, I noticed something though. If I factor a 2 out, I have an x minus 1, and this is an x minus 1 to the fourth, so I hope you see this. This x minus 1 cancels with one of these and leaves 3 of them, so I get 2 over x minus 1 quantity cubed. And that would be my second derivative. And I think we're done.